I will be speaking about Spack-Stack and interagency collaboration and Spack extension behind some of the leading NWP systems that we have in the United States. I listed only two of my co-authors here. The entire Spack-Stack effort is a lot bigger and everybody's involved. So speaking about complex systems, Samir showed that beforehand, NWP systems, numerical weather prediction systems, are complex too. Here you can see an example from the NOAA Unified Forecast System, the UFS weather model. It's got a bunch of submodules that are pink, and then there are also libraries that are gray. And this is a spaghetti diagram, pretty complex, but it's highly simplified because we are not showing Python dependencies here. There are no workflow components, no visualization, no lower level dependencies. So these things are difficult to build. And one reason for this complexity is that we do a lot of joint development these days. And that's, of course, a blessing because it means we can bundle our resources, we can be more efficient, we avoid duplication, we avoid making the same mistakes again. But on the other hand, it's also a curse because it means we're throwing a lot more constraints, requirements, dependencies into one system. And this is the climax of this is here as an example for it. That's the Joint Center for Satellite Data Assimilation's next generation DA system. It's called JEDI. It's supposed to replace all the DA components and the partner agencies that contribute to it. So that's NOAA, NASA, the Navy, the Air Force, the UK Met Office, NCAR. And so we have this complex system JEDI that must be able to build and run with all these models, UFS, GEOS, Neptune, MPES, LFRIC, and there's a fair bunch of ECMWF software underneath because of the involvement of Met Office. And then there are all these observation operators that you see here that are needed because of, and they come with their own sort of dependencies because they have proprietary data formats or pre and post processing tools and whatnot. So yeah, that makes it really complicated. And in order to help with that, we created Spack-Stack. It's an interagency collaboration, as I mentioned, made up of the Joint Center for Satellite Data Assimilation, NOAA Environmental Modeling Center, the Earth Prediction and Innovation Center, and then the Naval Research Lab. And we also have two users that don't contribute back yet. That's NASA and the UCAR Developmental Testbed Center. So a fair share of the US NWP enterprises sort of represents in one way or another in this collaboration. So the goal of Spack-Stack is to provide unified software environments for all our users and developers on HPCs, on the cloud, on commodity systems like macOS and Linux laptops. The premise is that it greatly simplifies the development and deployment of all the stuff that we need, like JEDI, Neptune, the UFS, and it does so by using community code, Spack, under the hood. Here's a little bit of history. We started Spack-Stack in late 2021 as what I like to call it a little garage project between two developers at JCSDA at NOAA. Back then, my colleague Karl Gerhasser, who since left for Intel, worked at NOAA on a system called HPC Stack. I worked at the Joint Center for Satellite Data Assimilation on JEDI Stack. They both look pretty similar. They share some common ancestors, but diverged. And we were both facing challenges that we thought were really hard to overcome if we just kept doing what we were doing back then. And specifically, we had this ever-increasing number of packages, HPC systems, compilers, and we also had the problem with these Python environments. How do we bake these Python environments into a software stack in a consistent way? So we were looking for other solutions, and we were both looking at Spack. And then instead of going on our own, we decided to bundle our resources there. So in the spirit of the European Center for Medium Range Weather Forecasting, the strengths of a common goal, we created Spack-Stack, and the idea was that we want to tap into the community for supporting this growing list of machines, cloud, compilers, and packages. But at the same time, we also wanted to ensure continuity for our developers, for the users, for the codes, like all these regression testing codes and so on, for the workflow components. And basically, that's what we're doing. So Spack-Stack works pretty much like the previous solutions, HPC Stack and JEDI Stack, used to work. All right, so we aim to release Spack-Stack every 3 to 6 months, and every one of these releases supports multiple applications and on many, many different systems. And the support for these applications is through the means of Spack environments. So we have environments that are tailored to specific applications. For example, we have a Neptune standalone environment for the Navy Neptune model. We have a UFS standalone environment, and so on and so forth. And each of these environments comes with a bunch of compilers. We're focusing on Intel and GNU at the moment, but LLVM is going to be added to the mix very soon. I wanted to draw your attention to one environment specifically. That's sort of the grand environment, the unified environment that contains everything you can imagine that you need to build JEDI and any of the partner models, Neptune, AMPES, UFS, GEOS. So we're talking about 315 installed packages, out of which 118 are Python packages. And at the end of the day, it's 12 gigabyte per compiler per environment and 160,000 files on disk. And so the selling point for Spack-Stack at our agencies is that this system is deployed everywhere in exactly the same way. So we do this on the Mississippi State University HPCs, we do that at NASA, at NCAR Wyoming, at NOAA NCEP, at NOAA Research, at the Navy, at the University of Wisconsin. We also do that on AWS, Azure, G-Cloud, and then Parallel Works, which sits on top of these cloud providers using Terraform. And we also have Docker containers that we use for CI. All right, so Spack is great, no doubt about this, because that's what we're here for. Why do we need Spack-Stack? Well, one of the observations is that most developers and sysadmins who work extensively with Spack sooner or later develop their own version of a Spack management tool. And if you look at the authoritative repository, that's kind of obvious because Spack is on purpose kept general. It's rapidly evolving. I mean, we're at pull request number 50,000 or something like that at the moment. And this rapid development often breaks the builds on platforms, especially the more exotic ones like, older craze and so on. So that's a challenge. So quite often we need to make updates to the Spack code, whether there's new packages or bug fixes for whatever system. And these PRs, despite the best efforts of the Spack team that I do not want to discredit here at all, can sit in the queue for quite some time, and we can't always wait. And then finally, not all the changes that we need to make are acceptable in the authoritative repository for whatever the reason may be. So the obvious answer to this problem is, okay, let's fork Spack and then build a little ecosystem around it. And that's basically what we've done. So if you look at the Spack-Stack repository here on the right, you see a bunch of directories, and each of these directories can be associated with one specific task or aspect. So we have a .github directory for CI testing. Most of this is on self-hosted runners at the various partner agencies. We have a configs directory where we have site configs, environment templates, container recipes. We have documentation that's tailored to our users, the systems, and the applications we support. We have the Spack fork, which is a fixed Spack hash that we update in a controlled manner whenever we are ready, that we use to keep the maintained differences to the authoritative repo, and that we also use to buffer pull requests. So we can submit the stuff there, keep moving, work the authoritative repository PR, and then bring that often updated PR back and keep stuff in sync. And then we have Spack-X, that's our Spack extension and the custom Spack repo. And we have a bunch of additional utilities such as automation scripts. So the Spack extension, I want to spend a minute on that one. Spack offers this powerful feature called extensions, which allows you to extend the Spack Python API and customize it to your needs. And we use that in the context of environments, containers, and modules. I will not talk about the containers here, but let's just look at the environments. So if you look at the call signature of Spack-Stack create env, then you find these typical arguments that you would expect when you think about customizing something fairly general. So you have a compiler, you can give the environment a name, it's got a site config, which is a pre-configured site. It's got an environment template, which contains numbers of packages and things like that. And then many more optional arguments, one of them being upstream environments that you can chain from. So that's pretty obvious. The other one at the other end of the development, the deployment cycle, is the setup meta modules extension, and that's a little unique in a set. So it runs after Spack module lmod tcl refresh. And what it does is it creates meta modules for the compiler, for the MPI library, and for Python. And basically it goes and looks at the compilers, the YAML settings, for that machine, and then bakes all these environment variables, RPath settings, and whatever else into the meta module. This basically means that we don't need to tell users, developers, or codes, oh, first you need to run these 17 commands before you can load a Spack environment. That's all baked into the meta module. And then on top of that, importantly for us, is that it modifies the Spack-generated TCL modules so that they work exactly like the LMOD modules. In other words, we basically implement the missing module hierarchy feature in TCL so that they act exactly like LMOD. The result of that is that the user experience for Spack-Stack is the same regardless on which machine you're on and which environment modules or which kind of module system it uses. You start with a module use statement, then you load 3 modules, stack-compiler, stack-mpi, stack-python. And then you can go off and load individual modules as you want, like HDF5. Or you can be lazy and say, I don't care, just give me everything I need to build Neptune version 1.5. So the point here is that everything that's in white, in white font, in white letters in this gray box is identical, regardless of which system you're on. The things that change are those yellow colors, depending on what machine, what environment, what compiler is available. Word of caution here, if you got curious, you want to look into the set of meta modules extension, you may well do so. However, that's one of these examples in history of code development where I sat down on an afternoon and said, oh, I'm going to write up something real quick. And then I come back a month later and do it properly. And that was 3 years ago and it never happened. So that's in desperate need of a rewrite. But it works. All right. So I mentioned before that we're not the only ones doing Spack management tools. There are many, many others out there. And I picked one other example to highlight some of the common features. And I picked Spack Manager for no good reason other than that I recently attended a talk to it and I learned about it. So Spack Manager is developed at Sandia Labs by Phil and his team, and then there are projects downstream projects that use it, and one of these examples is Exawind at NRL, and John is sort of leading that. So thanks to both of them for helping me with that slide. So if we look at what Spack-Stack and Spack Manager use from Spack, what kind of features, we both fork Spack develop so that we have a stable hash to point to. We both use Spack extensions. We use custom repositories. We use the ecosystem to store our site configs and specific documentation. We both leverage environments and views. Spack Manager has built-in support for install, load, and develop for users, Spack install, load, develop. We don't have that yet, but we're looking into it because it will help us with some of the stuff that we try to achieve. We're both using environment modules, and there's a fair emphasis on continuous integration and automation, whether that's GitHub Actions or in our case, Jenkins and cron shell. So to wrap things up, first, Spack is instrumental in our efforts to deploy complex unified software environments. It can't be stressed enough that without Spack, we wouldn't be able to do what we are doing today. 2, Spack is intentionally designed to be general, but it offers powerful features to customize it and integrate it with your respective needs and workflows. And 3, many groups working with Spack sooner or later come up with their own Spack management tool. I showed you 2 beforehand, there's a bunch more, and there's a fair amount of overlap naturally because we all try to achieve the same things. So the obvious question is, are there any opportunities for collaboration? And if so, how would that collaboration look like? Is that something that the Spack team at Lawrence Livermore would like to organize or facilitate, or in which way would the Spack team be involved, if at all? Or is that a hands-on thing from LLNL and we have to do this ourselves as a community? I'm curious to hear your thoughts about this, so thank you for your attention.
Needing some behavior different, needing to fork Spack in some way. And some of these things look kind of like maybe porcelain commands on top of Spack, to use the Git analogy of plumbing versus porcelain. What percentage of this do you think are things that you would like to see us integrate into Spack itself, and what and how much of this do you think is stuff that really has to remain outside because of the development model issues that you mentioned?
I'm not sure if I will answer it if I answer what you're asking really, but if we have a bunch of maintained differences that we need to keep separate for either because you don't want them or because there is just no way to get them into the code base. So one example I can give you is that CMake has a rule that if you do something like find package CMake and you're using environment module and you're using environment variables that point to these install directories with _root, then the package name has to be case sensitive and the root is all uppercase. Spack doesn't do that. Spack uppercases the entire environment variable that it creates. So for example, for HDF5, HDF5 would be capital and an _capital root. And that creates a bunch of warnings whenever you run CMake. So we have this maintained diff that we say, okay, we preserve the case name for the package as it's supposed to be, and then we capitalize the root so that we don't have those CMake warnings. So that's one of the maintained differences that we need to have. We also have a bunch of packages that we are not able to push upstream because they are restricted, especially Navy, DoD, and things like that. So this needs to be stored somewhere else. I don't know if that's answering your question.
Any other questions? Phil?
So when you look at the investment that you guys have made and how well Spack-Stack is working for you, and then you look this final conclusion here on opportunities for collaboration, I guess at a higher level, like what would it look like to collaborate, and how much of Spack-Stack, based off of where it is, would you organizationally consider rewriting in the name of collaboration? Because it would be like another investment. And so I'm just curious on your thoughts there. It's one of the things that I've been thinking about organizationally for my teams. What is kind of that crossover where we want to collaborate versus be separate?
Yeah, that is an excellent point, and I don't have a good answer for that. So hopefully we can engage in some sort of discussion around that. In my naive thinking, I would say that that feature that we have with this making TCL modules look like LMOD, that's something that's really useful because it gives you a lot more options and flexibility for using modules on the different systems. I think that would be beneficial if we were to rewrite this and then share it, for example, with you so that you could do TCL LMOD as well. On the other hand, you've spent quite a bit of time to write up documentation and tools around the spec install and spec develop process, which is something that we don't have yet. So yeah, it's a bit of a discussion. An example where we didn't engage with other efforts is going back to the previous discussion or the previous presentation on the binary caches. So we have talked with Samir and his team on the E4S binary cache, but after having played with it for a while, we realized that we don't gain enough from that, and it's fairly easy for us to create our own binary caches and keep that separate and do that, the way we need to do it. So I think it's a case-by-case thing.
Okay, thank you, Dom.